Josh, can we discuss hydraulic hose?
Maybe this is an issue for HR to discuss.
No, I mean hose like tubing.
Oh, that's a totally different thing than I was thinking.
You've been watching way too many rap videos, Josh. So anyway, what can you tell us about the component type of hose?
Well, early hydraulic systems were installed on large machines, which meant they were stationary beasts, and as a result, their plumbing systems could be hard-plumbed. When someone discovered the usefulness of hydraulic actuators weren't limited to stationary machines, the first hydraulic hoses had been invented to allow motion between two moving points, such as a boom. Although hydraulic pressure could be contained within a cylinder with leather V-packing seals, a simple consideration of the units we use to describe pressure helps in understanding the initial difficulties in manufacturing flexible conduits. Pounds per square inch. A square inch is about the size of a very large postage stamp. Imagine stacking hundreds of pounds in that little square inch, and you can imagine what engineers were up against, especially considering only natural materials were available as a solution a century ago. We take for granted now, but imagine you stood barefoot on a tall Lego block and then pile on a couple tons on your shoulders, and that's what a hydraulic hose has to withstand from the inside.
Ouch. So what was hose made from early on?
Early hydraulic hose was made from inner carcass of natural rubber surrounded by textile or yarn windings for strength. They would add an additional weave of textile on top for abrasion resistance. A hose construction of this sort would remain in production for a surprisingly long time, and I still come across the occasional hose with cloth outer carcass.
Wow.
To be fair, early hydraulic systems didn't run much pressure, and even 1,000 psi was difficult to achieve.
Sure.
As the requirement for high pressure evolved and the capabilities to construct components advanced, so too did the capabilities of hydraulic hose advance. The addition of steel wire to the outside of the rubber inner core provided a boost to the pressure rating. By braiding the steel wire in a hydraulic hose, you add resistance to radial expansion, but allow flexibility in bending. To further strengthen the hydraulic hose and increase its pressure capacity, multiple layers of steel braiding were added. Each layer was separated by an additional rubber layer to prevent metal-on-metal abrasion, and eventually hydraulic hose was nicknamed after the number of steel braid layers, such as two-wire hydraulic hose.
Okay.
As typical for any industry, various forms of hose construction evolved, and some hoses would apply spiral-wound hose of textile or steel, with multiple spirals being wound in opposite directions. Eventually, high-tensile strength steel would make its way into the market as well, further improving pressure capacity of hydraulic hose.
Well, I'm sure synthetic rubbers changed the game a bit too.
One of the biggest leaps in hose technology occurred then. Buna-N or nitrile is the most popular rubber used in hydraulic machinery because it's stable over a wide temperature range and has compatibility with most hydraulic oils. With modern materials and construction, hydraulic hose is both now strong and reliable and capable of pressures running 5,000 psi or more for years.
Sure.
Hoses with 4 layers of wire braids are now common in hydraulic systems, especially in those on large diameter running high pressure, such as excavators. Hose construction material and technique will continue to improve as pressure rises in hydraulic systems, and I suspect the use of synthetic materials will pave the way to the progress.
All right. Well, that's all the hose that's fit to print. Hopefully you'll check out more of our videos online at fluidpowerworld.com. Thanks for watching.